And we are given the general term of the sequence, and that is -1 raised to n plus 1. If you remember doing this, I'll choose another. Over 2 to the nth power minus 1. Have we seen this one? Yes? Should I pick another?
Wait, no, never mind. No, yeah, that was good.
Okay, very good. So we're asked to find the first 4 terms of the sequence. So A1, I replace n by 1 everywhere. So it's -1, 1 plus 1 is 2 over 2 to the first power minus 1 is 1. -1 squared is 1, 1 over 1 is 1. This is okay. Now for a sub 2, or the second term, -1 to the third power over 2 squared minus 1. But -1 to the third power is -1. 2 to the second power is 4. 4 minus 1 is 3. So the second term is -1/3. A sub 3. Is this okay? A sub 3, or the third term, -1 raised to the fourth power over 2 to the third minus 1. -1 to the fourth is 1. 2 to the third is 8. 8 minus 1 is 7. So the third term is 1/7. And we also want the fourth term. So A4 is -1 to the fifth over 2 to the fourth minus 1. The top is -1. The denominator is 16 minus 1, which is 15. So this is -1 over 15. So please make sure that the signs alternate. The first is positive, the next is negative, the next is positive, the following is negative. Yes, Marcus?
Okay, so you only go for the
Depending on what the problem is asking. You may be asking for the second and the third.
Oh.
I don't know. It depends. This problem is on, so it says write the first 4 terms of each sequence, whose general term is given.
Okay.
So depends on what the problem is asking.
Okay.
Very good. Next question. Anything else that you would like to see? Yes. Anything.
Number 12 on the test request.
Yes. I am. Yes. Can you give it to me? Oh, that's awesome.
Yes. It says to use the calculator to solve the equation and express the exact solution. E to the 11, well, as an exponent, 11x minus 5 minus 3 equals 28,498.
Perfect. Okay. So obviously this is what type of equation? Perfect, because the variable is the exponent. If the variable is in front of e, I can no longer say that it's exponential. But the only variable I see in this equation is at the exponent level, so it must be exponential. If I see the absolute value with x in it, then it has to be absolute value. If I see a square root with x underneath, it will be a radical, and so on and so forth. So now, always remember, in algebra and in math in general, we have to simplify and factor. So I can't go ahead and apply a procedure that I would normally apply here before I clean it up. There is no reason for us to have 2 free terms, one on the other, one on one side, one on the other. So I will definitely add 3 to both sides. So I have e raised to 11x minus 5 equals, what do I have here? 105, I think. Correct me if I'm wrong. 498 plus 3 is 501. Now, this is completely cleaned up, meaning it's completely simplified. There is nothing I can do to it other than thinking of applying a mechanism to both sides that removes the power, undoes the power if you want. And there is only one function that does that. If I had something squared, the function that I would have applied would have been the square root. But here I have to undo the process of exponent. And there is only one function that does that. So what function do I use or apply to both sides that will make the power come down and change the equation to a linear equation? It's the inverse the inverse function of e to the x. The inverse function of e to the x is, it's on the same key in the calculator. E to the x and its inverse are found on the same key in the calculator. Which one? Exactly. Only natural log is the function that allows us to move this power in front as a factor. No other function. If I try to take the square root, if I multiply, if I square, and no other process will allow us to bring the power down. This is the only one. If we apply, because here's the idea. If two numbers are equal, their logs must be the same in the same base. So now I'm allowed to put the power in front as a factor, and I should multiply by natural log e. But how much is natural log e? Okay, I don't know. Natural log e is a number. I know that this is equivalent to an exponential equation. I don't see the base here. It just says ln. I don't see a base. What is the base? Same key. Both are in the same key in the calculator. What could be the base? Let's take a look. The graphing calculator. So we remember this. See right here? ln and e are on the same key. Right? So ln must have base e because log has base 10. They're inverses of each other. So 10 to the x and log are inverses of each other, so they have to have the same base. E to the x and ln are on the same key. They must have the same base. So when I see ln, I say, oh, okay, base e. If I see log, I say what? Base 10. So e raised to which power is e? So the base, counterclockwise, starting with the base. E raised to which power is e? E raised to this equals e. Oh, I'm sorry. Sorry. How much? E raised to So let me just refresh your memory. What are we trying to do? So I'm putting 11x minus 5 in front, but I should write multiplied by natural log e equals natural log to 8501. My question is, what is this? Because I want to omit it if it's possible. So now I'm trying to determine how much is natural log e. The base, which is, one more time, natural log has which base? E. E raised to which power is e? E raised to which power is e? Exactly. That's why we will replace it by 1. So then the equation becomes 11x minus 5 equals natural log to 8501. Now this becomes linear because natural log of 28,501 is just a simple number. It looks sophisticated, but it's just the outlook. It's not. What do I do next? It's a linear equation. How do I solve the linear equation for x? And divide by. That's it. Now this is the exact answer. If they want an approximation, we have to put in the graphing calculator. Is that what they want also? Just exact. This is exact. Now, if you want to check, you can, but I would approximate it first and then check. Let me know if you want to do that. Yes? Okay, so let's do that. So with a calculator, please. Don't forget parentheses around the numerator. Always. 5 plus natural log 28501. Oops. Close the parenthesis for the log, close the parenthesis for the numerator, and divide everything by 11. So whatever that is. Now the equation was e raised to, so I'm checking now, second and e, in parentheses, 11 multiplied by the previous answer, and it was minus 5, close the parenthesis, come down, negative 3, and minus 28498. This is how I would like to check it. I moved that right term to the left-hand side. When I click enter, what should the answer be? Assuming that that is the correct answer. 1.3871. What should I get when I hit enter? Exactly 0. If I don't get 0, something is wrong. This is the calculator or the software saying 0. What does this mean? 0.7015, and that is 0. Your calculators may give just 0, plain 0. This software gave me 0.7015. Very good question. Next one. Anything else? Anything else? Other types of problems that we wanted to look at? Okay, in that case, I don't want to waste time. Let's choose. I choose something if you don't want to pick. Yes? Do I get to choose, or you want to choose? Okay. Do we want to condense and expand log expressions? Yes? Okay, so let's do that. Let's look at number 8, which is log base 5 of the 7th root of 6, s raised to the 6th power times t divided by 25. We are asked to expand this expression. Okay. Where is the starting, where is the starting point? What do I have to address first? Where am I looking? To expand it, I have to start with the power. So this is a power. What power is the 7th root? And that power has to go in front. That's the starting point. The 7th root is power. Which power is the square root? So yes, because I have to remove this first. So is it clear that x to the 7th and the 7th root of 7 cannot be the same? Right? So x to the 7th power cannot be the same with the 7th root of x. Right? So when I talk about this, there is no way that I can talk about power 7. Because power 7 is something like this. So it must be something else. 1 over 7. Any root is a rational exponent, not an integer, because if it's an integer, then it's x to the 7th. Is that clear? So it's the same for the difference between x squared and the square root of x. This cannot be power 2, because this is power 1/2. This is power 2, correct? So then I put in front 1 over 7, and then log base 5 of s to the 6th times 10 over 25. So now I have to look at log applied to a ratio, right? And I see there are 2 quantities at the top and 1 quantity in the denominator. How many quantities will have positive in front of the log, and how many will have negative in front of the log? So I see 1, 2, 3. How many will have negative in front? How many will have positive in front of the log? If the quantities come from the top, they will have positive in front. If the quantities come from the bottom, they must have negative in front. Should I review the properties of logs? Should we refresh our memory on the properties of logs? Yes? Yes, very good. So, and I'll come back to this in a moment. So we have log applied to a product, A times B, which is the sum of logs, log A plus log B. And also going back, if I have the sum of two logs in the same base, then it's log applied to a product. Now, if we have log of A over B, not log A over log B, which is something else, this will be log A minus log B. As you see, this quantity B comes from the denominator. It has a negative in front. So, of course, I can also go backwards. And there is one more rule that we already applied here, which was log applied to a base raised to an exponent. The exponent goes in front as a factor. So something like log of A to the x power is x multiplied by log A, which is the power rule. And these are the only properties of log. There is nothing else. We cannot simplify log of applied to x plus y. We cannot, if it's plus or sum. We cannot simplify log of A minus B. There is no such rule, but just these three. So now when I see a ratio and I see a product at the top, I see obviously these two will have positive in front because they come from a product, from this. But this quantity, the 25, is like B in the denominator here. So that's why it will have a minus in front. So 1 over 7, bracket. And please dictate now what we have in brackets. Yes. So log base 5 of s to the 6th. Log base 5 of t. Exactly. Log base 5 of 25. Perfect. We have one more step, however, because this is completely simplified. This one in the middle is completely simplified, but this one is not. There is one more rule that I can apply to the first one, and then we will discuss the last one in a moment. So what can I do to the first one? There is one more rule that I can apply. Which rule is that? We have to put 6 in front because we're applying this rule. Exactly. So 6 in front. And also let's identify what this is. Log base 5 of 25. So log base 5 of 25 is a number. But this is equivalent to 5 what? How do I write the equation for this? 5 counterclockwise. 5 raised to this number equals 25. 5 raised to this number equals 25. And now I'm thinking that that number can only be 2. So then this will eventually be replaced by 2. So let's write the final form now. We are also distributing 1 over 7 to all three terms. So 6 over 7 log base 5 of s plus 1 over 7 log base 5 of t minus 2 over 7. And this is completely expanded. We applied all properties. We applied the product, the quotient, and the power rules. Okay. Is this clear? Yes? Okay, so let's look at the exponential equation. Did we do number 10? 9 raised to x plus 4 equals 81 raised to x minus 2. If we did, we can move on to another problem. Okay, so what type of equation is this? Yes, because the variable is the exponent and nothing else. Good. So now I'm really trying to see first. Trying to see what? I'm checking what first. And you can say, why don't you just apply log to both sides and you're done? True. But there is an easier way. What is the easier way? Checking whether both sides can be presented with the same base. I'm not very fond of bases that are not prime numbers, but in this case it works if you can even use 9. 9 on this side and 9 squared on the other. This is what I recommend. Can you solve the equation by simply going ahead and applying log? Yes. Will you get the same answer? Of course. But I think it's easier if we notice that both sides can be presented with the same base. So then the left-hand side is 9 raised to x plus 4. The right-hand side is 9 raised to which power? Say it again. I have to multiply these two. Copy the base, multiply the exponents. Yes? Yes, very good. 2x minus 4. Two numbers are equal and they have the same base. What must happen here? What do I have to write as a conclusion of that? I have to write that this will happen in only one way, or with only one condition. Which one? Okay, so let's look at this. 9 raised to 15 equals 9 raised to 30th. True or false? Absolutely false. So let's come back. Two numbers are equal and they have the same base. What must happen? Exponents have to be the same. No other way. There's no other way. This is linear. I move 2x, I get negative x. I move 4 and I get negative 8. So therefore, x equals 8. Is this okay? Would you like to look at problem 14 with the logistic growth function? Do we want to look at that? Okay, very good. So let's work on that one. So here's the function. It's a logistic growth model. I'm going to copy the function f of t, 104,000 over 1 plus 5,400 e to negative t. The logistic growth function describes the number of people, I'm taking notes, number of people, so I don't forget, who have become ill with the flu t weeks, so t is in weeks, after its initial outbreak in a particular community. How many people became ill with the flu when the epidemic began? What am I asked to do and how do I do it? Is this blurry? It is. Sorry. Is this better? Sorry about that. So, how do I determine how many were ill initially? And then how many people were ill by the end of the 4th week? And then the limiting size of the population. So what am I asked to determine in part A? Perfect, awesome. So f of 0. And what am I asked in part B? Very good, awesome. I'm not going to plug this in each individually. I'm going to go to y equals. I have to check this because the computer resets. No, that's not what I meant. The resets, yeah, it does. Make sure that your independent variable is in the ask mode. And let's go to y equals and plug it in. The top is 104,000. Since it's only one number, it does not need parentheses. Divided by, in parentheses, 1 plus 5,400 times e to negative x. E to negative x, in parentheses, please, negative x. Close the parenthesis and then close the parenthesis for the denominator. So we have to see this. So some sophisticated calculator may not require parentheses around the power. Maybe, maybe not. I would not take the risk. I will put parentheses for the power and definitely parentheses around the denominator, because otherwise the calculator will only divide 104,000 by 1 and add the rest, not divide by the whole thing. Okay? So now I go to second and table, and I plug in 0, and then I plug in 4. And for the limiting size of the population, the number of weeks increases without bound. Okay, 40 weeks later, 60 weeks later, 100 weeks later. So what do I copy for f of 0? 19 people. What do I copy for 4 weeks? 1041 people. And after numerous weeks pass by, what is the size of the population that could become ill? The entire community, not more, assuming no visitors, because otherwise it will be more. Very good. Okay, so let's look at something else. Let's see what else we want to practice with. What about problem 15? Let's take a look at 15. The figure on the right shows the graphs of the cost and revenue functions for a company that manufactures and sells small radios. How many radios must be produced and sold for the company to break even? The break-even point is when the revenue and the cost equal each other. There is no profit. So revenue equals the cost. So I'm going to copy the cost function, 18,750 plus 19x. I'm going to copy the revenue function, which is 49x. And we're asked to find how many radios are produced for the company to break even. So what do I have to do? Exactly. So 18,750 plus 19x equals 49x. What type of equation is this? Of course, I move 19x to the other side, I get 30x, 18750, and then I determine x dividing both sides by 30. So how many radios? How many? 625 radios. Now, what if we're asked what is the break-even point? We will say 625, and how do I determine the y-coordinate? Plug it in, it doesn't matter where. I can plug it in here, or I can plug it in here. They must be equal. For 625, they must be equal. How much? in case we're asked to find the break-even point. 30,620. Thank you very much. Okay. Would we like to practice a Gauss-Jordan now? Yes? I don't remember if we did this one. This is number 18. I don't think we did 18. We did? Okay, let's choose another then. Let me look. This is section 6.1. I have the book right here. If you want to choose, if you have the book and you want to choose, please do so. Page 631. Or I will choose. Okay, I will choose 32. 3a plus b minus c equals 0. 2a plus 3b minus 5c equals 1. A minus 2b plus 3c equals negative 4. This is a system with how many equations? How many variables? So it's a so-called 3 by 3. Good. Is it arranged in the correct order for Gauss-Jordan? Yes. So can anyone dictate the augmented matrix, if you want, by columns or by rows? It doesn't matter to me. Very good. Very good. Perfect. Very good. This is the augmented matrix. Remember, the sequence of steps is carved in stone. We cannot change the sequence. We cannot make any adjustments to that. The first step is I need a 1 here at all costs. I have, let me refresh your memory, we're only allowed 3 row operations. We can swap rows if we want. Second one, we can multiply or divide any row by a non-zero number. And the third one, which is the most sophisticated one, is this. We multiply one row by 2 and add the answer to another row. Or by 5, or by negative 3, or whatever we need. But first I have to start with a 1 here. How do I get that 1? Exactly. That's the easiest thing to do. So I'm going to say row 1 now becomes row 3, and row 3 becomes row 1. Excellent. Remember, we do not write the equal symbol between these matrices. So 1, negative 2, 3, and negative 4, and 2, 3, negative 5, and 1, and 3, 1, negative 1, and 0. So our first accomplishment is this 1. What is the next step? Let me refresh your memory on the steps. 1, the corresponding zeros. 1 in the middle, the corresponding zeros. 1 at the bottom, the corresponding zeros. So now I have to get rid of this and this. So therefore, I will be using which row? It's always the same sequence. First I use row 1 and do something with it, then I will use row 2, and then eventually row 3. So row 1, multiply by something and add it to row 2, and row 1 multiply by something else and add it to row 3. And now I need to figure out multiplied by what? I need to multiply this 1 by something and add it to this 2 and get 0 instead of 2. What will I multiply 1 by to add it to this number and get 0? Of course. Now the same thing. What do I multiply 1 by and add to the 3 to get 0? Very good. Which row do I copy? because it will be the only row that does not change at this point because I am using it. Yes, it has to be row 1. So 1, negative 2, 3, negative 4. Let's do this together slowly. Here it is. 1 times negative 2 plus 2. Negative 2 times negative 2. 4 plus 3. 3 times negative 2 minus 5. Negative 4 times negative 2 plus 1. Ugly. 7, negative 11, and 9. Okay, next one. 1 multiplied by negative 3 plus 3. Negative 2 times negative 3 plus 1. 3 times negative 3 negative 9 minus 1. And negative 4 times negative 3 plus 0. Okay. Very ugly, but that's fine. Let me just check that I copied the system correctly. 3A. Yes, I copied that correctly. It's fine. I mean, I don't know the answer. I'm just making sure that I copied that. Yes, I did. Let me see that we copied 3, 1, negative 1, 0. 2, 3, negative 5, 1. Correct. 1, negative 2, 3, negative 4. 1, negative 2, 3, negative 4. Yes. 3, 1, negative 1, 0. 2, 3, negative 5, 1. Yep. I don't see any error. So 0, and that's 4 plus 3. Negative 6, negative 11, and that's 8 plus 1, 9. Negative 3, yes, 6 plus 1, 7. Negative 9 minus 10, correct, 12. Good. Okay, so I need to get a 1 in here. I have no choice but divide both sides by 7 or this row by 7. Row 2 divided by 7. It's getting ugly because of the fractions. One, negative 2, 3, negative 4, 0, 1, negative 11 seventh, 9 seventh, 0, 7, negative 10, and 12. It is what it is. Now, I have all these, they're done, and I have this. Now I need to eliminate this number, and I need to eliminate this number. Which row do I have to use? And it makes sense. It's the next in line, which is row 2. Row 2 multiply by something and add it to row 1, and row 2 by something and add it to row 3. Let's identify what we need to multiply by. What do I need to multiply by 1 so that when I add it to negative 2, I get 0? One more time. What do I multiply 1 by so that when I add it to negative 2, I get 0? Very good. What do I multiply 1 by so that when I add it to 7, I get 0? Very good. Awesome. Okay. Which row do I keep now intact because I'm using it? Exactly. So 0, 1, negative 11 seventh, 9 seventh. And remember, I cannot destroy the first column. That is now carved in stone. Okay, so let's do this together. 1 times 2 minus 2. Very good. Negative 11 halves, seventh times 2 over 1 is negative 2 over 7, and I have to add it to 3. Negative 22 over 7 plus 3. Remember, I need to multiply by 7. So this will be negative 1 over 7. 9 over 7 times 2 over 1 is 18 over 7, but I have to subtract 4. So that is 18 minus 28. So negative 10 over 7. Okay. 1 times negative 7 plus 7. 1 times negative 7 plus 7. Good. Now this is nicer. Negative 11 over 7 times negative 7 is 11. 11 minus 10 is 1. 9 over 7 times negative 7 over 1 is negative 9. Negative 9 plus 12 is 3. Okay. All this is by chance. Most all of it is accomplished. Right? This one I said it is by chance. So now the last step, we have to multiply row 3 by something and add it to row 1, and row 3 by something and add it to row 2, of course. And this will be the very last step. Okay. So what do I multiply 1 by so that when I add it to negative 1 over 7, I get 0? Very good. What do I multiply 1 to add it to negative 11 over 7 to get 0? Yes, very good. So then, 1 times 1 over 7 minus 1 over 7 is 0. 3 times 1 over 7 is 3 over 7. Minus 10 over 7 is negative 7 over 7, which is negative 7 over 7, which is negative 1. Perfect. Okay, last question here. 1 times 11 over 7 minus 11 over 7. Perfect. 3 times 11 over 7 is 33 over 7 plus 9 over 7 is 42 over 7, which is 6. We really hope there is no error with all these fractions. So assuming there is no error, we'll figure it out in a moment if there is. Assuming there is no error for now, what do we get? Negative 1, 6, and 3. We go back to the original problem in which I replaced negative 1, 6, and 3 in that order. Negative 1, 6, and 3, negative 1, 6, and 3. Let's try. Negative 3 plus 6 is 3. 3 minus 3 is 0, yes. Negative 2 plus 18 is 16. 16 minus 15 is 1. Negative 1 minus 12 is negative 13. Negative 13 plus 9 is negative 4. So only now, indeed, I can say, yes, there is no way there is another, or this is wrong, because it is correct.